All right, so today marks the start of Module 6, which covers Chapter 7. We're skipping Chapter 6. We'll be on this until December 4th, so basically 3.5 weeks. We have half a week off for Thanksgiving. And then we'll have a week of review in preparation for the final exam. So there's a lot of stuff in this Chapter 7, so let's jump right in. So Chapter 7 deals with arrays and the array list class. In particular, we'll look at an introduction to arrays, processing array contents, passing arrays as arguments to methods, some useful array algorithms and operations, returning arrays from methods, string arrays, arrays of objects, the sequential search algorithm, parallel arrays, two-dimensional arrays, arrays with 3 or more dimensions, the selection, sort, and binary search, and command line arguments, and finally the array list class. So as I said, a lot of stuff, okay? So up to this point, we've been dealing with primitive variables, which are designed to hold one value at a time. So when we create a variable of type int, it holds one int. So using what we know so far, let's imagine we needed 100 ints. Okay, using just primitive data types, what would that look like? Well, talk me through it. Int A, comma B. Okay, all right, and then I need 100 of them, so what happens after you get to Z? AA, AB, okay, we get the idea. Tedious, right? Probably don't want to do that if we can avoid it. So that's where arrays come in. Arrays offer us a way to create a whole bunch of variables with just one line of code, 1 or 2 lines of code. So arrays allow us to create a collection of like values that are indexed. Each array can store any type of data, but only one type of data per array. So if we create the array to hold ints, it will only store ints. If we create the array to hold chars, it will only hold chars, etc. And we call those individual variables, we refer to them as elements, okay? So here's syntax for creating an array. We have int square brackets and then the name of the array. So it looks a lot like creating an individual variable, easy for me to say, except that we have the square brackets after the data type. So that creates the array. Then to declare the array, we have to decide on the size of the array. So this line, numbers, which again is the name of the array, equals new, that's a keyword, new. Then the data type again, int, and the square brackets. So inside the square brackets, we have to provide a whole number, non-negative whole number. And that determines the size of the array. So this line of code creates an array with 6 elements. However, keep in mind that the index value of the first element is always 0. Okay, so the first element has an index value of 0. So therefore, in this example, the last element has an index value of 5, which is a total of 6 elements. Questions so far? Good. We can also combine those two statements into a single line. So we have int square brackets, then the name of the array equals new int square brackets, and we provide a number there. And again, that determines the size of the array. Here are some other examples that use different data types, but they're all arrays. So this first example here creates an array of floats, and it's going to have 100 individual variables in it, or 100 elements. The next example is 41 characters, and so on. A common approach that is used is to create a constant that stores the size of the array. Then whenever we're dealing with that array, we can refer back to that constant, including in the declaration of the array. So in this example, we create a constant called array size. Remember that keyword final is what makes this a constant. We give it a value of 6. So the value of this constant array size will never change. It will always be 6. Then we can use that constant array size when declaring the array. So again, this is another way to create that same array called numbers with 6 elements, all of type int. Very important, once you create the array, the size is fixed and cannot be changed. So you need to think very carefully about how many elements you're going to need to store. If you don't know exactly, then you need to overestimate a little bit. You don't have to use the whole array. So if you declare for 100 elements and you only use 50 of them, that's okay. Not very efficient, but it's okay. The program's not going to crash. On the other hand, if you create space for 100 elements and you actually need 200, well, you're stuck. You can't increase the size of the array after that. To access the elements of an array, we use the name of the array, square brackets, and then a number inside the square brackets. That number inside the square brackets is called the index, and that correlates to the individual element in the array. The way we pronounce this orally is with the word sub. So the array element at index 0 is pronounced numbers sub 0 if the name of the array was numbers. Okay, so numbers sub 0, numbers sub 1, numbers sub 2. Each of those elements has their own unique value. So now that we've seen that, let's go back to our example. I want 100 ints. Let's do it with an array. What does that look like? That's part of it. You need a little bit more. You have to get the keyword new in there. So you're almost there. Int array equals new, and then you would actually, I believe you would go int 100. Let me make sure. Okay, so again, there's different ways to do it with the syntax. We'll explore the different approaches, but this combines the array creation and the array declaration in one line, and this will give us 100 ints. That's a lot better than saying int a, b, c, d, right? Good. So let's look at some examples that use arrays. Array demo 1. So this example, we're using the scanner. So we're getting some data from the user. We have a constant here. Employees is assigned the value of 3. So there's going to be 3 employees. Then we create our array and declare it to hold 3 elements. So we have an element of type int, or excuse me, an array of type int called hours, and it's going to have 3 elements because that's the value of employees. Okay, with me so far? Then we prompt the user to enter the number of hours worked for employee 1, employee 2, and employee 3. Something worth noting is that employee 1, the hours for employee 1, are being stored in the array element with the index of 0. Okay, and employee 2 is being stored in the index 1, array 3, and index 2. So there's an off by 1 thing going on. And there's a good reason for that, right? The array has to start at 0. And we don't want to give an employee the number 0. That might be degrading or something. So we start at number 1 for the employee number, even though that correlates to an index value of 0. And then we display that data back to the user, but again, using the array. So the purpose is just to show that the array is working. So let's go ahead and run this. And give me some numbers.
6, 20.
Okay. And so those are the numbers that we're taking in. Those are the numbers that are displayed out again in the same order that we entered them. Okay? Questions on that example? All right, now array demo 2 does the same thing, but it does it in a more efficient way. I changed this in an earlier class. Let me change that back to 3. So it starts out the same, but here's where it gets different. Instead of hard coding the index values, we use a loop. And this is a really powerful combination. For loops and arrays were actually designed to go together. So they can do some very powerful things. So in this example, we have our index starting at 0, and it's going to count to 1 less than the value of employees. So let's walk it through. The first time through, index is 0. So we have the print line, employee, then we concatenate that with index plus 1. So the user sees 1, right? But that gets, when the user enters the data, it gets stored in the array element at index what? It's still 0, right? So it displays employee 1, but stores it in hours sub 0. We repeat the loop. The user sees what? 2, but it gets stored in index 1. Repeat again. The user sees 3, and it gets stored in 2. Very good. Repeat one more time. What happens? Index becomes 3, which is no longer less than employees. So that evaluates to false, and the loop ends. All right? So it repeated 3 times. Then it says the hours you entered are, that gets displayed to the screen. And we have this for loop, which displays the data back to the user. So again, the index counts from 0 to 2, and it simply displays the array value at each of those elements. Okay, so let's go ahead and run that. All right, give me some numbers. 18, 21, 4. So there they are, displayed back again using arrays, but this time doing it with a for loop instead of hard coding the numbers. So in addition to obviously having less code to type, there's another very important advantage to doing it this way, which in fact is such an advantage that it makes certain problems possible, which the solutions to certain problems are possible because of this combination of loops and arrays that otherwise would not be possible at all. But just to illustrate how powerful this is, if I want to increase the number of employees in this program, what do I need to change? That's right. So I just change that value to whatever I want. I'll make it 5. And the rest of the code is written, it kind of revolves around that value. So everything else just updates automatically. The size of the array goes up because it's declared using that. These loops count differently because the upper value has changed in a correlation with employees. And so everything else just works in correlation to that new number of employees. So let's go ahead and run that. We're going to have 5 values this time. Let's get somebody other than Cody. Come on, wake up. Give me some numbers. 10, 15, 25, 40, 43, and there they are. So by changing just that one value in one line of code, we made the entire program expand to handle more employees. Cool. Very important that we do not exceed the bounds of the array. So sometimes we need to do bounds checking, or just be careful about how we use the array. Make sure we do not exceed the upper bound. And this can be a common error because of what we talked about, how the number of elements in the array is actually 1 more than the index value of the last element in the array, right? So if we declare the array to hold 10 elements, the last index is actually 9 because it goes 0 through 9. So what happens if we try to access an element that's outside of the bounds? Well, let's find out. So in this example, we create an array that holds 3 elements, and then this loop tries to access the element at index 0, then 1, then 2, and then 3. Is that going to work? No. So let's see what it does. Get a big old nasty error message. You will get error messages as you program. I promise it. I guarantee it. It's very important to be able to read them and understand them. So let's look at this error message. It says array index out of bounds exception 3. So what that's telling us is that that index value of 3 was out of bounds for the array. Then at the next line, it's telling us which line of the program caused the error. So we'll look at line 17. I always suggest that you keep your line numbers turned on in whatever IDE you're using. So we look at line 17, and so we know that it's this array where we exceeded the value. Okay? So why is that? Why was 3 outside of the bounds of this array? Right. The index values are 0, 1, and 2. There is no element at index 3. So it's out of bounds. So we could fix this by perhaps changing this to 3. Then the program would run. It doesn't do much, just stores a value, but at least it doesn't crash now. Okay? Questions so far? So again, you want to watch off by 1 errors. This is probably the most common error for programmers that are first learning how to use arrays. Here's another way that an off by 1 error might occur. So this array is declared to have 100 elements, but we have a for loop here that's designed to count from 1 to 100. So there's actually 2 problems with that. What are the 2 problems? Not starting at 0, so we're leaving out an element of the array. We're going out of bounds because it counts to 100, but the index of the last value is 99. Okay? So the first problem, the fact that we started at 1, that's not going to cause a compilation error or anything. It's just inefficient because we're leaving out the first array element. But the second error, going out of bounds, as we just saw, that's a serious problem. That causes a compilation error. Another way to create an array is to declare it and initialize it to have some values all in one line. So in this example, we have an array called days of type int, and we give it a bunch of values as shown here. So what that does is it determines the size of the array and gives every element in that array a value, all in one line of code. So in this example, days sub 0 is assigned 31, day sub 1 is assigned 28, and so on. So let's look at an example that uses that. So here we have the array being declared and initialized. Then we have this loop. The variable index will count from 0 to 11 and display month index plus 1, so month starting with 1. But when we display the values of the array, index is 0, so days sub 0 the first time through. So let's go ahead and run that. I think you can predict what this will do, and I bet you also know what this is supposed to represent. All right, so it displays month 1 as 31 days and so on. Okay, so it basically tells us how many days are in each month of the year. Questions? So again, keep in mind that this declaration is declaring the array to have 12 elements. We can't add any more elements. Okay, so even though we didn't put a number in the square brackets, the fact that we initialize it to this list of values inherently determined the size of the array to be 12. There are a few different approaches with the syntax that are legal when it comes to declaring the arrays. So this is one of them. we start with the data type or object type, and then square brackets, and then the name of the array with a space in between, semicolon. So that declares the array. Another approach is to put the square brackets after the name of the array instead of after the data type. Okay, that is also allowed. Both of these are allowed, but the first one is more common. Then where this really can get interesting or a little bit hairy is when we want to declare multiple arrays in the same line of code. So in this first example, what we've done is we've declared 3 arrays, all of type int. Note that the square brackets are after int. Whereas in this example, all of these are of type int, okay, but the first 2 are arrays, whereas the third one is an individual variable. Doesn't have the square brackets. I personally recommend this style with the square brackets immediately after the data type. I find that to be a little bit easier to read. You are welcome to use the other style, but what I strongly suggest is that you pick one of the styles and stick to it. Try not to go back and forth between the styles because that may confuse you. Good, questions? So we can also do math with these values. We can handle them exactly the same way as other individual variables. So in this example, we have gross pay being assigned equal to hours sub 3 times the pay rate. So we can do that. We can multiply them, add them together, all kinds of things. So let's look at an example that uses that, payArray.java. So in this example, we have a constant. We have 2 variables of type double. Then we have the array declared to hold 5 employees. So it's going to hold the number of hours for 5 employees. Here we have a loop that we're using to read the data in. Then we're calculating, then we're getting the pay rate from the user. And in this example, it's just one pay rate for all of the employees. Then finally, we're calculating the gross pay for each employee, and that's also done with a loop. So the gross pay is equal to the number of hours for that employee times the pay rate. So let's go ahead and run it. Give me a number of hours. 26, 20, 7, come on, 17, 21. Okay, and the pay rate, 1850. Let's make it hard. There it is. Not hard for the computer. So we've calculated the gross pay for each of those 5 employees. So far, so good. Questions? Let's say instead of, excuse me, simply displaying the gross pay, what if we also wanted to store the gross pay for each employee? How could we modify this program to store the gross pay? Make another array. So we'll put that up here. And what would that look like? Yeah, I like it. All right, everybody follow this. So we created a new array. It has 5 elements in it, and we called it pay. So what we're actually doing is we're creating what's commonly referred to as parallel arrays. Parallel arrays are simply 2 or more arrays that store related information. So the idea here is that the index value correlates to the employee. So if we take the same index value and put it in the hours array, and use that same index value in the pay array, that information, the hours and the pay, is for that employee at that index number. Does that make sense? Do I need to say that again? So for example, if we have employee at index 3, right? If we take that index 3 and plug it into hours, that gives us the number of hours for employee at index 3. If we take that number 3 and plug it into pay, that, when we're done, will give us the pay for that employee at index 3. So the arrays are parallel. So now, how do we go about storing that data in the array? We'll keep this loop the way it is.
So instead of gross pay, can you do pay bracket employees or index?
Index, right?
Or gross pay?
Right. And just to show that it's working, instead of displaying gross pay, I'll display pay index. And let me change the name of this.
Oh, did we make it?
Doesn't like it. Let's see.
Should be
Required int found double. Okay, so pay needs to be double. Everybody follow that? The result of that mathematical expression is a double. So we need to, and gross pay is a double. So the array needs to be of type double. All right, give me some numbers.
40. 35, 30, and 26.
Hourly pay,
20.
2080. All right. So there it is. We've got some formatting issues. Not worry about that right now. The point is the array is storing the values correctly. Everybody with me? So that we just created our first parallel array. There's two arrays being used in conjunction with each other. We can also use arrays in relational operations, just like we can with other numerical data types. So for example, we could compare two different elements of the array, and this will come into play later when we learn about sorting arrays. Okay, so we need to be able to compare the different elements of the array in order to be able to sort them. We can also use the arrays as loops, as loop conditions. So we could have a while loop, and we could use one of the elements of the array as the condition variable that we're checking. So again, anything that you can do with any of the other numerical data types we've learned about, we can do with arrays, or with the individual elements of the arrays. Another property of arrays that we can use is the length. So the syntax to access that property is to simply have the name of the array, then a dot and keyword length. And that will return an integer, which is the size of that particular array. So this could be useful if we're not sure how big the array is. Maybe there's some other parameters in the program that determine the size of the array, so it's not so straightforward. But we can make sure we get the size of the array to make sure we don't exceed the size of the array, right? Because we saw what happens if we exceed the size of the array. Another loop that we have available to us is a variation of the for loop. It's called the enhanced for loop. Remember I said a moment ago that for loops and arrays were designed to go together. So this actually takes that a step further. this enhanced for loop only works with arrays. So the way this works is we have the keyword for, then the data type, the element variable, and the name of the array. So this element variable will count from 0 to the last element in the array. And we don't have to program in what that last element is. The enhanced for loop figures that out for us by accessing the array directly. Okay, so this can be really useful if we want to iterate through all of the values in an array. So in this example, we created this array to be of size 3. It has 3 elements. Then we have this for loop that counts through those 3 elements. So it's another type of loop to learn, sort of, but it can make your life a lot easier if you master it, if you need to iterate through the values of an array. So remember that if we're counting through a loop the old-fashioned way, we'll call it, with a for loop, not an enhanced for loop, we need to start at 0 and end at 1 less than the array length in order to make sure we get all the elements but don't exceed the size of the array. So let's look at an example that uses some of these concepts. Display test scores. All right, so we have an integer called num tests. Then we have an array of ints called tests. So in this example, we actually prompt the user for the number of tests, and then that determines the size of the array. So this shows that the size of the array can be determined at a later time as long as it's declared first. Then once we have that, we can then get the scores from the user. This is using a loop. Okay, again, when the program started, we didn't know how many tests there would be. So the fact that we're using a loop here allows it to be flexible, as opposed to hard coding, you know, enter test score and then a number, you know, and then the array element. You know, it's like we saw back in array demo 1. This is just a lot more flexible and a lot easier to handle. So let's go ahead and run this. So let's just, to keep it short, let's say we have 3 test scores, and we'll enter some test scores. Maybe it was out of 56. You don't know. Or maybe it was out of 23 points. Guess there's a lot of extra credit. But anyway, you get the idea, right? So the takeaway from this example is that the user can actually determine the size of the array if it's programmed correctly. Now, something that's a little bit tricky about arrays is that they're actually reference objects. So if we re-initialize the array, you can do it, okay? But the first array in this example with the 10 elements is gone. Okay, so if you were to do this, if you were to initialize an array to have 10 elements and then later reinitialize the array to have only 5 elements, it doesn't just lop off the last 5 elements. It deletes the entire thing. Okay, so it will be garbage collected if we were to do this. So the takeaway is, generally speaking, you don't want to do this. There might be some really unusual circumstances that might lead you to this. I can't think of any, to be honest. So, you know, the general rule pretty much applies. Once you declare the array to have a particular size, it's fixed. You don't want to change it. So what this looks like graphically, if we imagine, not imagine, this is actually how it works, that the array is an address, and the first address pointed to this list of 10 values. Then once we reassigned it or reinitialized it to have 5 values, the address is pointing somewhere else in memory entirely. So that memory that was allocated before is no longer allocated. It goes into the garbage collector. So this brings up another important point, is that if you ever need to copy an array, you may be tempted to do something like this. Declare the first array, give it some values, then declare another array and simply assign it equal to the first array. This will not cause a compilation error. However, it also will not copy the array. What it will do is it will cause the two arrays to point to the same address in memory. In other words, if you were to do this, then changing the elements in either of the array would also change the elements in the other array from that point forward. They would essentially be the same array with two different names. Okay, I can't think of a reason why you would want to do that, but let's look at what happens in the code just to explore it. So here we have array 1 initialized to some values, array 2 initialized to some values. Then down here we use an enhanced for loop to display the contents of array 1. And in between there, we change some of the individual values. Let's see what happens. So at first, array 1 has these values. Then array 2 is assigned to the same memory location as array 1. So when we change this element 0 in array 1 to 200, that also changed that value in array 2 because they're actually the same array. Okay, and same thing happened here. When we change a value in array 2 to 1000, that also changed that value in array 1. So the takeaway here is this is not how you copy an array. All right. We'll look at the preferred way to copy arrays next class, but right now I want to look at a gadget.